Welcome class to our video notes on the second part of Skill 5 from Unit 3, which again we are adding rational expressions, which is basically fractions, right? We're adding and subtracting, that should say and subtracting rational expressions. And the part 2 of this skill is focused on what to do when you start off with different denominators. Well, basically what you need to do is create a common denominator. So that'll be step 1, and that'll probably be the most challenging part of adding and subtracting rational expressions, is creating that common denominator. So it will involve finding an LCD, and this is a skill we learned how to do in our last video. It will also involve multiplying by fancy forms of 1, and you'll see what that means when we get to it, because we're going to be making each denominator the same. And so to do that, we have to basically multiply by 1, and then from there it's just like the part 1 video. You basically add across the top and then simplify if you can at the end. And then subtracting is also very similar. You need to distribute the negative to the numerator. That's basically the only difference between adding and subtracting. After that, you just follow the steps for addition. But I will emphasize that before we follow the steps for addition, before we even try to create a common denominator, you're going to want to distribute that negative first. Let's start with example 10, because remember, this is continuing from our previous outline. That's why we start with example 10. And this is an addition problem. And it's a whole number being added to a rational expression, which is basically a fraction with algebraic terms in it. So whenever you have a whole number or something that's written not as a fraction, you can write it over 1 to make it look like a fraction, so that you can work on trying to get a common denominator. This one starts off simple. The only thing in the denominator is an x, so that would have to be our lowest common denominator, would just be x. And the second fraction already has that denominator. We just have to give that denominator to the first fraction. So we're going to multiply by a fancy form of 1, right? Because we know that x divided by itself is equal to 1. So if I multiply 3 over 1 by x over x, then I basically, then the result of that multiplication would just equal 3, because 3 times 1 is 3. But we're going to, instead of writing it as 3, we're going to write it as 3x over x. And then meanwhile, I'll keep the second denominator the same. So this is what I have, 3x over x plus 5 over x. Again, this expression is equivalent to 3. I haven't changed the value of it at all because I just multiplied by 1, but it's written in a way that allows me to go ahead and add across the top because the denominators are now the same. And so that's what we do. Once we have a common denominator, we just go ahead and add across in the numerator, and I can see I've got like terms of 3x and 1x. So then the numerator ends up being 4x plus 5 all over my common denominator of x. And so this is my final answer for this first one. 3 plus the quantity x plus 5 over x is equal to 4x plus 5 all over x, as long as my denominator is never 0. And since the only thing in my denominator is x, then I can't let x equal 0. So in example 11, we have a little bit more complicated of an example. It's still adding fractions, and they both have something different in their denominators. So we need to make the denominator common. So what I'm going to do first is just look at my two different denominators, x squared minus 4x and 3x minus 12. And what we're going to do is factor each of those denominators, because I'm trying to create a lowest common multiple between the two denominators. We call that the lowest common denominator. In the first denominator, I can see there's a GCF of x. So I'm going to go ahead and take that out or divide it out. And so when I do that, I'm left with x minus 4. In the second denominator, I can see a GCF of 3. And when I take that out, I see that I again have a remaining factor of x minus 4. So when I go to create my lowest common denominator, I'm going to go ahead and use that common factor of x minus 4, and then the remaining factors of 3 and x. I think I'm actually going to put those in the front. I'll put the 3 and the x in front, and then our common factor of x minus 4. This was the skill we had learned in our last video, and I believe it will save us so much time when trying to find our lowest common denominator. So this is the lowest thing that both of the denominators can multiply into. And that is going to be critical. I need to be able to multiply something to this denominator to get it to equal that. So it might help actually if I rewrite each fraction with the denominator in factored form. So let's do that. And then what that helps me see is what part of the LCD each of these denominators is missing. And then I can multiply that part in. So the first fraction has the x and the x minus 4 from the LCD, but it's missing the 3. So I'm going to multiply the first fraction by 1, right? 3 over 3 equals 1. And then the second fraction has the 3 and the x minus 4 from the LCD, but it's missing x. So I'm going to multiply the second fraction again by 1, right? I'm multiplying by 1 both times. And the reason why that's important is because I'm not changing the value of these fractions. I'm just changing the way they look. I'm changing their appearance. But in value, they will be the same. So I am legitimately adding these quantities because they're not changing in value. Okay, so what I'm going to do with the 3 is distribute it to the numerator here. And then 7 and x just multiply together. So I would get on the left, I would get 15x minus 18, and then on the right, plus 7x. And that'll all be over my newly found lowest common denominator, which has 3. They both have 3, they both have x, they both have x minus 4. So that is my newly found common denominator. Notice I'm not distributing down here because I want to keep it factored so that at the end it makes it easy for me to tell if it will simplify or not. So I distributed in the numerator because I want to be able to combine like terms, because that's where I add, right? We don't add the denominators, we only add the numerators. So for that reason, I leave my denominator just like this in factored form. Okay, but now I'm going to go ahead and combine my like terms. So I've got a 15x plus 7x. So I'm going to add those together. I get 22x minus 18. All over a 3 times an x minus 4. And then at the very end, we like to check and see if anything will simplify with the numerator. I do notice I have a GCF of 2 in the numerator, so I'm going to factor that out. But when I do, I notice that the remaining factor is not in common with anything down here, because if I divide 22 by 2, I get 11. And if I divide 18 by 2, I get 9. So I can see the factors of the numerator are 2, and then the quantity 11x minus 9, and the denominator doesn't have anything in common with that, which means that it wasn't really necessary to factor to begin with, because it ended up not canceling out with anything, because that's all we're looking for. We're just looking to see if we can simplify anything. So we can leave our answer like this, but we do need to note that x can't be 0, and that's because of this factor of x right there. I'm not allowed to let it be 0, and then x can also not equal 4, and that's because of this factor here. If I plugged 4 in for x, this would become 0. 4 minus 4 would become 0, so I can't let x be 4 either. So this is my answer. This is what I get when I add these two fractions, and then these are the values for x I need to exclude. Okay, looking at example 12, again, it's another addition problem with 2 different denominators, and so I cannot add these fractions together until I make a common denominator, which is, again, the hardest part. So what I do is I just look first at the factors of each denominator. And for x squared minus 1, that's a difference of squares, so it will factor into x plus 1 and x minus 1. And then x squared minus 3x plus 2 is a trinomial, so I would need to use the trinomial factoring for that. So I need to find two numbers that multiply to positive 2 and at the same time add to a negative 3. The only way that can happen is if both factors are negative, right? Negative 2 times negative 1 is positive 2, but then when you add them, it adds up to negative 3. So those are my factors, x minus 2 and x minus 1. So when I go to find the LCD, I start with the common factor. They both have a factor of x minus 1, but then I still need to list the remaining factors. So there's an x plus 1 and then also an x minus 2. So my LCD has 3 distinct factors in it, and so what I need to do is make sure each of these denominators end up with those same 3 factors. So first I'm going to just rewrite the fractions with the denominators in factored form. And again, I do that just so I can easily see what I need to multiply to each fraction. Okay, so I can see the first fraction already has the x plus 1 and the x minus 1 from the LCD, but the one it's missing is x minus 2. So then that's what I will multiply to this fraction. X minus 2 divided by x minus 2. And again, I multiply by the same thing to top and bottom so that I don't change the value of the fraction, because basically what I'm multiplying by is 1, right? X minus 2 divided by x minus 2 is 1. So I can multiply by that to this fraction, and it's like I'm multiplying by 1. In the second fraction, I can see I have the x minus 2 and the x minus 1 from the LCD, but not the x plus 1. So that's what I will need to multiply to this second fraction. So I have to distribute the x in the first numerator, and then I have to full-on FOIL these binomials in the second numerator. So I'm going to do that and write it all over my common LCD that I have just created, right? I just created two fractions with the same denominator. In the first fraction, I have x squared minus 2x in the numerator. In the second fraction, I end up with 2x squared plus 2x minus 1x minus 1 when I FOIL all of that out. And then all of that is being divided by these same three identical factors. X minus 1, x plus 1, and x minus 2. Notice I'm not FOILing those out because I want to see if maybe something will cancel at the end. So I can see that my 2x terms, right, negative 2x and positive 2x, those will cancel. And I have two terms that both have an x squared. I can combine those. I'll think of this one as 1x squared. And I think that's it in terms of combining like terms. So I end up with 3x squared minus 1x minus 1. Right? 1 plus 2 is 3x squared. These canceled. I still had a negative 1x and a negative 1. And then all of that is being divided by x minus 1 times x plus 1 times x minus 2. So because I'm left with a trinomial, a quadratic, right, the highest power of x is 2, quadratic trinomial, I am going to just check and see if it will factor. So I'd have to multiply 3 to negative 1, which is negative 3, and then write the b coefficient on the bottom, and then look to see if there are two numbers that multiply to negative 3 and add to negative 1. And it looks like that's just not going to work, right? The only factors of negative 3 are negative 3 and 1, but that would add to negative 2. So this won't factor, which means this is the simplest form of the final answer. So this 3x squared minus 1x minus 1 all over x minus 1 times x plus 1 times x minus 2 is my final answer. And then if you look at those three factors in the denominator, I can tell that x would not be able to be 1 or negative 1, right? Or 2. X can't equal any of those because any one of those will cause the whole entire denominator to be 0. For example, if I plug x equals 1 into all these x's, 1 minus 1 would be 0. So I'd have 0 times 2 times negative 1. That's still all 0, right? Because it doesn't matter how many numbers you're multiplying to 0. Once you multiply anything to 0, it just makes everything 0. So 1 would make the whole denominator 0. So would negative 1, because negative 1 would make this factor 0, right? Negative 1 plus 1 is 0, and 0 times these two numbers is still 0. And then similar thing would happen with 2. 2 minus 2 is 0. So x cannot equal either, any of those values. So moving on to subtraction. If you recall, at the very beginning of the video, I said to distribute the negative first. Do that first before we try to find the LCD. It will save you, it'll help you avoid making mistakes with signs. So I'm going to take this subtraction, I'm going to distribute it right away before I do anything else. And so now this problem is 2 over x minus 5 plus, basically we turn it into an addition problem, plus negative x plus 3. So we just kind of turn it from being a subtraction problem into being an addition problem. And then we might have to FOIL this to something. And so it's just a good idea to go ahead and distribute that negative right away and just help avoid missing out on the negatives later. Okay, so we did that step. Now I'll go ahead and look at each denominator. And since both of these are basically in simplest form, like I can't factor x minus 5 any further or x. So the LCD in this case would be to simply multiply each of these unique factors together because they don't have any common factors. And you might be wondering, like, isn't x a factor of x minus 5? And the answer is no. The way I know that x is not a factor of x minus 5 is because it's not being multiplied to 5. It's being subtracted by 5. So that act of subtraction means that these are not factors, okay? So x minus 5 is a prime factor, and so is x, and so they just multiply together to create the LCD. So basically what I need to do is multiply this first fraction by x over x, and then multiply this second fraction by x minus 5 over x minus 5. I'm basically multiplying by 1, right? X over x is 1, x minus 5 over x minus 5 is 1. Then I will go ahead and FOIL again the numerators on the second fraction, and I'll put all of it over my common denominator. So I have, from the first fraction, I have 2x. From the second fraction, I have negative x times x would be negative x squared. Negative x times negative 5 is positive 5x. 3 times x is 3x, and then 3 times negative 5 is negative 15. So I have all of that in the numerator. All of that is being divided by my LCD of x times x minus 5. I'm going to go ahead and combine my like terms again. I actually have 2x, 5x, and 3x that can all combine. And I'll go ahead and put the x squared term first. So negative x squared plus 7 plus 3 plus 10x, and then minus 15. So that is what my numerator turns into. And then in the denominator, I have x times x minus 5. So because, again, it's a quadratic trinomial, I should just check and see if possibly it can factor and maybe cancel with one of these. So I'll do a times c. Negative 1 times negative 15 is positive 15, and then there's a 10 here. So I would need to find factors of 15 that add to 10, which again is not possible because there's 15 and 1, but that would add to 16. Or there's 5 and 3, but that would add to 8, right? And then I could do 2 negatives, but the negatives would add up to a negative number, not positive 10. So it's just not going to work, okay? So we just kind of quickly look and see if maybe it'll work, and it won't, which means it doesn't cancel, which means this is our simplest answer, right? That's our answer right there. And then based off these two factors, I can see that x cannot be 0. Otherwise, this would turn into 0, or 5. Because if x were 5, then x minus 5 would turn into 5 minus 5, which is 0. So I need to exclude these two values. In example 14, again, right away, I want to distribute that negative to the 4 and think of this as an addition problem. So I'll think of it as c over c plus 5 plus negative 4 over c squared plus 8c plus 15. I do that first before I even start looking for an LCD. Now I'll start looking for the LCD. So for that, I just look at the two different denominators and see what their factors are. Well, the first denominator is just c plus 5, so that's like a prime factor. That is the only factor. C squared plus 8c plus 15, that can factor because I can think of factors that would multiply to 15 and add to 8, and those are 5 and 3. So those are the factors, c plus 5 and c plus 3. So then I do notice they have a factor in common. So my LCD is going to equal that common factor of c plus 5 and then times the remaining factor of c plus 3. So basically, my LCD is just the second denominator. But I'm going to keep it in factored form because it makes things a little bit easier. In fact, I'm going to rewrite this problem with the denominator in factored form. So the second denominator is just the LCD already, c plus 5 times c plus 3. So I notice I don't need to multiply anything to that second denominator at all. It already is the LCD. And then I just noticed that my first denominator is missing the factor of c plus 3. So I just need to multiply the first fraction by a fancy form of 1, right? I'm multiplying by c plus 3 over c plus 3 because that equals 1. So it doesn't change the value, but it does change the appearance to have a common denominator. And I do need to distribute the c here in this first fraction. So I get c squared plus 3c minus 4, right? When I go ahead and combine the numerators, because now I have a common denominator, so I can just add the tops. And then I'll go ahead and keep my denominator in factored form. And then I am going to check and see if I can simplify, because I notice again in my numerator I end up with a quadratic, right? Highest power was 2, trinomial, right? 3 terms. So I'm going to see if there are two numbers that multiply to -4 and then at the same time add to 3. And this one does factor into +4 and -1. So I'm going to factor the remaining numerator into c plus 4 and c minus 1. But turns out that wasn't really necessary, again, because these factors have nothing in common with the denominator. So you can either leave your answer like this, or since you did the work of factoring, you could leave it like that. It's fine. And then you just have to exclude -5 and -3 from the domain, or from the c. From c. C cannot equal those values, because if it did, then my denominator would turn into 0, and I would be dividing by 0, which is undefined, so we exclude those values there. Last but not least, we come to number 15, which is a little different. It's just different. It's not using these polynomials, it's using these monomials, just single terms that are all combined through multiplication. But the idea is the same. I need a common denominator, so I'm going to look at the factors of each denominator and then find the LCD between them. So if I look at xy squared, it's a factor of x and 2 factors of y. If I look at 2x cubed, it's a factor of 2 and then 3 factors of x. So we basically only have one common factor. So when we're trying to find our LCD, we will use that. So maybe I'll put that here. So I have one common factor of x, and then I have all these remaining factors. So I need a remaining factor of 2, and then I need the other 2 x's, because those are remaining factors, and then I need the other 2 y's. So this was the common factor of x, and then these were the remaining factors. So my LCD would be 2x to the third y squared. Okay, and I'm going to rewrite this fraction so that the denominators are factored. Okay, so I have 5 over x times y, and then, oh yeah, I forgot to distribute that negative. That's important. So this is really an addition problem. I'm really adding -7y. This will just help me make sure I have my signs correct later. So I'll write that here. So I've got -7y over 2 times x times x times x. So I can see very clearly what's in each denominator, and then I can also see what needs to be in each denominator. So from the first denominator, I am missing the 2 and 2 x's. So I'm going to multiply by 2x squared over 2x squared to the first fraction to make sure my denominator has all of this, a 2, 3 x's, and 2 y's. And then I notice in the second fraction, I'm missing the y squareds. So I'm going to multiply y squared over y squared to that second fraction so that it has all of the same things in the LCD. Okay, so now I'm going to just go ahead and multiply all of this out, right? So this first numerator, I have 10x squared. And in the second numerator, I have a -7y cubed. So I'm going to put -7y cubed. I don't really need to think of it as adding a negative anymore, really, because I'm not going to be able to combine these like terms anyways. Might as well just think of it as subtraction. 10x squared minus 7y cubed. And then all of that is over my LCD, right? Both of these denominators have a 2, have 3 factors of x, and 2 factors of y. And there's not really any way to factor the numerator, so I'm not going to be able to simplify this at all. So this would be my final answer in terms of subtracting these fractions. but I can't let x be 0 and I can't let y be 0 either, because both of those variables are in the numerator and being multiplied to other things. So if either one of them were 0, then it would turn these denominators into 0, which would make them undefined. So therefore, we restrict these values. Okay, so that concludes our Skill 5 notes, both parts 1 and 2, and I'll see you in class.